Hello everyone, welcome back to my channel. I am Nandini. Today I am back with a new video. We're gonna discuss some topics in the machine learning subject. The first topic is the supervised learning algorithms. Supervised learning is a type of machine learning where the algorithm learns from labeled data. It's like having a teacher who provides example with correct answers. The algorithm uses these examples to learn patterns and make predictions on new or unseen data. Next is the unsupervised learning algorithms. Unsupervised learning is a type of machine learning where the algorithm learns from unlabeled data. It's like exploring a dark room without a flashlight, trying to find patterns and structures in a data on its own. This is often used for tasks like clustering, anomaly detection, and dimensionality reduction. First is a clustering. Group similar data points together based on their futures. Think of organizing people into groups based on their hobbies. Anomaly detection. Identify unusual data points that don't fit the typical pattern. Think of finding fraudulent transactions in a financial data set. Dimensionality reduction. Simplify complex data by reducing the number of futures while preserving important information. Think of summarizing a long text document with a few key phrases. Next topic is the end-to-end machine learning projects. End-to-end machine learning projects involves all the steps from data collection and pre-processing to model training, evaluation, and deployment. This approach ensures a holistic perspective and addresses the entire life cycle of a machine learning solution. Let us see some key points. Data collection. Gather the relevant data from various sources, ensuring its quality and completeness. Model selection and training. Choose the appropriate model based on the problem and train it on the prepared data to learn patterns. Deployment and monitoring. Deploy the trained model into the production environment, allowing it to make predictions and continuously monitor its performance. Data pre-processing. Clean, transform, and prepare the data for model training, addressing missing values and inconsistencies. Model evaluation and tuning. Evaluate the model's performance on unseen data and fine-tune its parameters to improve their accuracy. Next topic is the support vector machines and kernel types. Support vector machines are powerful supervised learning algorithms that excel at classification tasks. They work by finding the optimal hyperplane that separates different classes of data points. Linear kernel, a simple kernel that draws a straight line to separate points. Next is a polynomial kernel, allows for unlinear boundaries creating curves to separate data points. Next, third one is a radial basis function, that is RBF kernel. Use a Gaussian function to create flexible boundaries that can handle complex data distributions. Next is the sigmoid kernel, similar to the RBF kernel, but it uses the significant creation of nonlinear boundaries. Next is a bagging and pasting ensemble methods. Ensemble methods combine multiple machine learning models to improve overall performance and reduce the risk of overfitting. Bagging and pasting are the two common ensemble techniques that work by training multiple mode is on and different subsets of a training data. Bagging samples data with replacement, creating multiple training sets. This helps reduce variance and improve model stability. Pasting sample data without replacement that creates the training sets. This helps to improve the generating or reducing the overfitting. Next is the Bayes theorem and Bayes classifier. Bayes theorem is a fundamental concept in probability theory that helps calculate the probability of an event given prior knowledge. It forms the basis for the Bayes classifier and a simple yet powerful supervised learning algorithm. Bayes theorem calculates the probability of an event given prior knowledge. Bayes classifier classifies the data points based on their probability of belonging to the specific class. Next is a bias in belief networks. Bayesian belief networks are probabilistic graphical models that represent relationships between variables and their dependencies. They use Bayes' theorem to infer probabilities and make predictions. First is a node, represents a variable like a future or attribute. Edge connects nodes, indicating a dependency relationship. Probability table specifies the probability distribution for each node given the states of its parent node. Next is a decision tree training and visualization. Decision trees are supervised learning algorithms that use a tree-like structure to make the predictions. They split the data into subsets based on their futures, creating branches that lead to the final decision node. First is a training, the process of learning the structure and parameters of the decision tree. Visualization is graphical representation of a decision tree or the decision rules and their relationships. Next, let us see some of the advantages and disadvantages. Machine learning algorithms have both advantages and disadvantages. Choosing the right algorithm for a specific problem depends on the data characteristics and the desired outcome. Advantages are easy to understand and interpret, can handle both categorical and numerical data, flexible and adaptable to different problems. Disadvantages are prone to overfitting, can be computationally expensive for large datasets, sensitive to outliers and noisy data. Conclusion is that machine learning has revolutionized various industries by enabling the computers to learn from the data and make predictors. Supervised, unsupervised, and reinforcement learning algorithms are powerful tools for solving a wide range of problems. So, finally, thank you for watching. Please do like, share, and subscribe to my channel.